So I hear you want to learn how to solve systems of equations, huh? I don't know. I just feel silly today. Anyway, let's get started. Here you can see my first example here. This is what I'm going to do in this video for you. I'm going to show three different examples on how to solve them three different ways, which is equal values method, substitution, and elimination. All right, and then I'll create additional videos just going in depth into equal values method, and then another video for elimination and so forth. All right, so let's get started with this one. But don't just sit there and watch this. Make sure you write this down. This is a good example to have as part of your notes. We have 2x. We have 2x plus y equals 5. And then the second equation is y equals x minus 1. Now, I said we were going to write them in solve it using the equal values method. So that means I have to have each one of them written in the form y equals mx plus b. All right, you can see the second one is already written in that format. So I'm just going to go ahead and rewrite this one. All right, so let's take it here to the side. Let's see here. Basically, I'm going to move the 2x over here and leave the y behind. I hope you understand the process here. There's another video I have on how to solve equations and stuff like that. So hopefully you know how to solve them by now, because you're doing this. Of course you should. So we have y equals negative 2x. It would be plus 5. Plus 5 because this is a positive 5. And all I did was move this one over here through inverse operations. So I subtracted 2x here, subtracted 2x here, and this is what I end up with. Now this is my equation here, and my other equation is y equals x minus 1. So all I'm going to do is right now set them equal to each other. All right, so let's do that. Let me give me some space. So we got x minus 1 equal to negative 2x plus 5. All right, at this point, all I need to do is combine like terms. So I like to move the small ones with the larger ones and so forth. So obviously this is smaller because it's negative. So we're going to add 2x here, add 2x here. And this eliminates this right here, leaving the 5 behind. Remember, this right here is my equal sign. And this right here becomes x plus 2x gives me 3x, and I have the minus 1. All right. Now, next, what I want to do is combine that 1 with the 5. So inverse, that would be plus 1 on both sides. And we end up with a 0 here, giving me 3x equals 6. Last step, divide both sides by 3, and we get x equals 2. Okay? X equals 2. Now, remember, this is the number one mistake. Most people stop right here and say, x equals 2. I'm done. No, you're not. Okay, you're not done. This is a system of equations. Basically, what we're doing is finding where these two lines, because these two equations are lines, intersect. Where do they intersect? And as you know, they intersect in an ordered pair. So therefore, what I have to do is I have to take this value here of x equals 2 and plug it into one of my equations. You get to choose which one. And obviously, you can see the first one, which is x minus 1. That would be the easiest one, right? So we have x minus 1, and I'm going to plug in the 2 there. So 2 minus 1 equals 1. So this right here is my y value. Okay, this is my y value. So I have my x and I have my y. So therefore, final, I have 2 comma 1, which is my point of intersection. That's what it means. All right, there you go. We just solved a system of equations using the equal values method. All right, now let's find another one, and let's do another one of the methods. Here we go. Okay, so as you can see here, we have this system of equations, which is 2 equations here, and we're going to use the substitution method. All right, now make sure you label these. If you wrote down the last one, label it equal values method so you know what method was used there. Label this one substitution. All right, we're going to use the substitution method. Substitution. All right, so substitution. Now basically, and especially when it's written in this format, like the last one was, I could have done it in the last one. So this one has This one right here has y equals 3x. Excellent. All right, because I want you to look at here. I have a y right there. So that means the value of that y, right? The value of that y is 3x. So I'm just going to substitute here this in there. It will look like this. 2 times 3x, and the rest is just written. Minus 5 equals 4. So you just rewrite the rest. So this right here would be 2 times 3x is 6x minus 5x equals 4. All right, hope you're following along. Remember to pause if I'm going too fast for you. Now here 6x minus 5x gives me 1x equals 4. So the value of x equals 4. But remember, we have to find the y value. You can't just leave it like that. So let's take x right here, and we're gonna, the value of x, which is 4. We're gonna plug it into the first one because it's the easiest one to solve. And so this would just look like this right here. It would be y equals 3 times 4. So y equals 12. And there's my value of y. So therefore my final answer is 4, 12. That's the point where those two lines intersect. All right? Substitution method. Pretty easy. All right, which is one of my favorites actually. Let's move on to the last one, which is elimination. All right. All right, so here we go. We have 2x plus 7y equals 13. We have 2x plus 3y equals 5. So, as you can see, we're going to use the elimination method. And basically, you want to be able to eliminate one of the variables, either the x or the y. It doesn't matter which one. Just try to be, what you're looking for is see if you can eliminate. If you cannot eliminate one, then you would use one of the other methods, the substitution or the equal values method. But in this one, as you can see, I'm looking at this. I got a 2x and a 2x here. Well, that's telling me right away that I can eliminate these if one of these was negative. All right. My question would be, can I turn the 7 into a 3 or the 3 into a 7? No, not likely, right? I want to be able to eliminate them, and I want to be able to just change one of the values to negative, or the opposite, positive or negative, to be able to eliminate it. So in this case, I'm going to choose the bottom one. I can choose the top one, doesn't matter. But this right here becomes an addition problem. And what I'm going to do is I'm going to take the whole equation. Remember that saying, whatever you do to one side, you got to do to the other. So I am going to change this 2x to a negative. That means I'm going to change everything to the opposite, because right now that everything's opposite, everything's positive. And I'm going to do that by multiplying it all times -1. Now the question often comes up. Well, could I have multiplied by 2 if I needed to make it a 4? Yes, you can multiply by 2, by 3, by 4, whatever it takes in order to make it the opposite of the other equation so that you can cancel one of the variables. So in this case, what do we have here? We're going to have negative 2x minus 3y equals -5. Okay? Remember, because this -1 distributes times 2x times 3y times 5, giving me everything as an opposite. All right? Now, I am going to add these two equations together to eliminate the -2x. So I have 2x plus 7y equals 13. And then the other one now is -2x minus 3y equals -5. All right. Now this whole thing is an addition problem, so don't get confused. We have 2 plus, right? 2 plus a -2. Well, that's exactly what I wanted. I wanted to eliminate this. So now it's a 0. Now, right here, I have 7y plus a -3y, which is going to give me a positive 4y. And then here I have simply, I have 13 plus -5. So 13 plus negative 5, that's going to equal, I'm losing, I can't add, 8, right? And so, yeah, it's a positive 8. Losing it here. So I have 4y equals 8. Now, simple. Divide both sides by 4. And I get y equals 2. So my value of y is 2 because I eliminated the x. Okay? Now, as the previous equations, I'm going to take this 2 right here and I'm going to substitute it into one of these two original equations. Which one, it doesn't matter. In this case, yeah, it really doesn't matter, right? So I'm just going to pick the second one here. So let me get some space here. So let's write the second one. 2x plus 3. Now, don't write the y here, right? Because we have a y right here. That's where we take off the y and put in the 2. So, times 2 equals, and then 5. That one there is just 5. All right? So now, what we're going to do here is just to begin to solve it. We have 2x plus 6 equals 5. Now, combine like terms right here, the 6 and the 5, we have 2x equals negative 1, right? Because we're subtracting 6. Let's get some space here. And last step, divide both sides by 2. We have x equals negative 1 over 2, negative half. So that's the value of x. And right here, I have the value of y. Let's write them together in an ordered pair. We have negative half and 2. Once again, what does that mean? That means that if I graph these two equations, they will intersect on the graph at that very precise point, negative half, 2. All right? Well, I hope you have an understanding now of how to solve systems of equations through elimination, through substitution, and through equal values method. All right? Look out for my next video where I go more in depth into each one of them, doing at least 3 examples of each one. All right? You guys have a great day, and thank you so much for coming to Math Quiz. Don't forget to subscribe. All right. You guys take care. Bye-bye.